live. Okay, so it is 12:4, 19. Okay, so find the missing angles and sides of this triangle. So before we even start, what I have is a triangle, and of course this is notes for the kids who weren't here. It's not a right triangle. It's not a right triangle. So there is no hypotenuse. You can't use the sine, cosine, and tangent ratios on this triangle because it's not a right triangle. That stuff is right triangle trig. It's not a right triangle. So what do? Well, first of all, in order to use the law of sines, which we have already talked about in class, law of sines, you first have to know a pair of opposites. The most important thing, you have to know a pair of opposites. So if I look at my picture here, I've got a 40-degree angle and a 5. Those are opposite. I got an angle and opposite side, okay? So if you're going to go ahead and do that, then the ratio is sine opposite side over the sine of its angle equals opposite side over the sine of its angle. So it is going to be as easy as this. Okay, so 40 and 5. Here's my 6. So let's find this angle because that's its opposite, right? I've got a pair of opposites. I like that. I have my pair of opposites. I've got 40 degrees and 5. Here's my 6. So again, it's all about opposites. All about.
Which ones are opposite 1 and opposite 2?
Doesn't at all. Nice question. You have to have a pair of opposites, so it doesn't matter at all. In fact, what I like to do is, me personally, I like to write down what I want to find first. So I'm going to do this. I'm going to go, okay, sine of theta over 6. So sine of my angle over the side equals sine of 40 degrees over 5. So it's sine of an angle over its opposite side, sine of an angle over its opposite side. Once you have it set up, then we're just going to cross multiply and solve. So I'll take the 6 and I'll multiply it up, okay? So I'm going to have sine theta is equal to 6 times the sine of 40 over 5, right? Make sure my calculator's in degree mode. We've talked about that before. Double check your mode, degree mode, right? If you get some weird answer, that's usually the first place I go is degree mode because my pre-calc kids are using these calculators also. So I just type this into my calculator just like that. Okay, I'm going to go 6 times the sine of 40. Close the parentheses. Close your parentheses. Divided by 5. And I get a decimal. That's not an angle. But what I have to do is if I want to find the angle, I've got to take the, see if I got sine of theta is equal to 0.7713. But that's not the angle. So I have to find the sine inverse of that 0.7713, blah, 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 blah. So I'm just going to go, in my calculator, I'm going to go sine inverse of that answer, I think about 50.5 degrees, right? Hi. Come on in. I don't, God, I know, and I'm even recording. I know, isn't that awful? I'm going to give you my notebook and have her take my notebook home, okay? All right. So 50.5 degrees. Okay, let me get a notebook set up, okay? Autumn, come on up. You're teaching, okay? Keep going, okay? So now, what's Autumn going to find next?
On this one?
What can Autumn find, right? Yeah, it's on number 1. Number 1's not done.
Oh, we're not?
No, so on number 1, we're missing that third angle, aren't we?
Oh, okay.
How would we find that third angle, you guys?
Well, you subtract it from, well, you can add those and then subtract from 180.
Yeah. And then just have it like, you bet, okay? So add them up, subtract from 180, right? Does that make sense, everybody? Keep going, Autumn, you're doing great. Okay,
What?
you're doing great. Subtract from 180.
I'm just going to use
Gotta be
calculator.
180 this time, not 90, because there's no 90 in it. Yeah, Isaac?
Why wouldn't you use the other formula? Or like the second one we used in the other?
That's the other side.
Oh, for the angle.
I mean, the other
Going
one.
to, yeah, yes.
Other
yes,
angle,
yes.
sorry.
So all she's doing is find that third angle, right? So the third angle, you got 2, Isaac, two angles, right?
Yeah.
Find the third, just add them up, subtract from 180. You with me?
Well, no, what I meant was like, why wouldn't you use like sin of theta 1 over opposite 1 instead of,
Oh, because you don't know it's opposite.
oh, okay.
Right? Okay, now. Awesome. And now let's find the opposite. So let's find this side. How are you guys going to find this side? Do you have a pair of opposites? Right? And even here, could you find an opposite? So what Autumn had to do is she had to get this angle first. So you get the opposite. That makes sense? So if we have to find this, let's call it x. Okay? We'll just do our opposites. Opposite, 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 or I like the 5 and the 40 because those are better numbers, right? So I'm just going to go, okay, opposite side, x over the sine of 89.5 equals 5 over the sine of 40, okay? So I have a side over the sine of its opposite angle equals a side over the sine of its opposite angle. Now you could have used the 6 and the 50.5. I could have, right? But I just chose the nicer numbers, okay? And then cross multiply, right? Bring the sine of 89 up here. So I'll have x equals 5 times the sine of 89.5 degrees over sine of 40 degrees, and I'm just going to use my calculator, right? 5 times sine of 89.5, close the parentheses, divided by sine of 40, and I get an answer of about 7.77 or 7.78. Okay, what do you think? Not too bad? Okay, let's look at example 2. Okay, now, do you have a pair of opposites? No.
So you have to find the other angle.
Ah, smart girl. There you go. Find the other angle. Will you have a pair of opposites?
Yes.
Yes. So let's call this theta. Thanks, Julia. Let's go 180 minus parentheses 82 plus 70. Let's find that other angle. I totally agree. So we're going to go, nice job, Julia. And then we get our opposites, don't we? 82 plus 70. And I get an answer of about 28 degrees. So I'm going to put 28 degrees in here for theta. 28 degrees. Okay. Now, do you have a pair of opposites? Yeah, we do. So we've got opposites. I'm going to circle them so you guys see it. So I've got my opposites. Circle my opposites. Opposite. Right now, you have two choices. You could either find this side, let's call it x, or this side, let's call it y. Does not matter. Dylan, what do you want to find? Do you want to find the x side or the y side? It doesn't matter. What do you like?
X.
X it is. So you got your opposites then also, right? So you're going to go opposites, opposites, right? You guys see your opposites, right? So let's set it up. You're going to go x over the sine of its opposite side angle, which is 70 degrees, equals a side, which is 13 over the sine of 28, okay? So it's side over the sine of its opposite angle equals side over the sine of its opposite angle. Does this seem easy? Easy as I think it is? Okay, then cross multiply. I'll bring up the sine of 70, right? And I'll have x is equal to 13 times the sine of 70 divided by the sine of 28. And I'll go 13 sine 70 divided by sine of 28. Oops, 28. And I get an answer of about 26. Okay, now let's find y. Don't use Pythagoras' theorem. Don't be using Pythagoras' theorem. How come? Why can't we use Pythagoras' theorem? It's a right triangle, so what do you have to do?
You have to do the same thing.
Same thing, exactly. It's just going to do the same thing, except for Dylan chose X. Now, Dylan, we got to choose Y, don't we? So let's do the same thing, but this time we're going to choose Y instead. So we're going to go opposites, right? So we'll go y over the sine of 82 equals 13 over the sine of 28. I could have used the other two sides, but I like to stick to numbers that are good numbers, okay? Same thing, multiply up the sine of 82, right? Multiply that up so that y is equal to 13 sine of 82 divided by sine of 28. And I'm just going to use my calculator. 13 sine 82, close the parentheses, divided by sine of 28, and I get an answer of about 27.4, okay? What do you think? Thumbs up? Okay, you ready to turn the page? Now, the law of sines also helps us find area. Now, normally with area, like if I take a look at this example and I wanted to find the area, right? Area of a triangle, base times height divided by 2, right? I don't know the height. I don't know the height, right? I could use a little right triangle trig, and I could draw the height in here, and I can go tangent, blah, 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 get the height, base times height. There's an easier way. So there's another formula, okay? It's a sweet formula. You do not need a right triangle. The formula is this, okay? Now, I put adjacent because they're both next to it, right? There's no opposite, there's no hypotenuse, right? So I got adjacent, either adjacent 1 or adjacent 2. So the area of a triangle is this. Area is equal to 1/2 the adjacent side times the other adjacent side times the sine of your angle. It's a nice formula. It makes finding an area of a triangle really easy. You don't need the height. I could prove it to you someday why that works, but you probably don't want to see it. But this is a nice formula, okay? I'm going to highlight that, okay? So how does it work? Well, if I take a look at my triangle here, and I want to find the area of this, I'm going to use my formula. I'm going to go area equals 1/2. Adjacent, either 5 or 6, it doesn't matter. Autumn, you're going to ask that anyway, it doesn't matter, right? So let's go 6 times 5 times the sine of 58 degrees. I'm just going to use my calculator. Wasn't that easy? So I put in my calculator. I've got it. 0.56 times 5 times sine of 58. And I get about 12.72 centimeters squared. Okay, pretty easy day. You guys agree?